Hey everyone, and welcome to this explainer. I'm so pumped you're here today because we are unpacking something absolutely mind-bending. We're looking at a groundbreaking theoretical physics paper by Dr. Rihan. It's called Innovative Application of Faraday Quarters and Euler's Formula to Wave Functions. Okay, I know, that title is a total mouthful, right? But what Dr. Rihan is actually doing here is giving us a literal blueprint of reality. He's mathematically deconstructing the architecture of the universe, starting right inside the atom. And, as we're going to see, he uses some seriously elegant geometry to pull it off.
So let's dive right into the massive question at the center of all this. If the universe is just packed to the brim with energy, why is the inside of an atom mostly vast, empty space? You've probably heard the analogy before, right? If you scaled an atom up so its nucleus was the size of a marble sitting on the 50-yard line of a football stadium, the electrons would be like tiny gnats buzzing way up in the highest, furthest bleachers. And everything in between? Just empty. But why? For a long time, physics kind of just treated this as a given probabilistic quirk. But today we're using Dr. Rihan's framework to uncover the universe's mathematical secret source code, a code that actually forces this empty space to physically exist.
But before we get to the empty space, we first need to look at the tools that build the atom. Let's look at section 1, reality's rotation engine.
All right, let's talk about this really fascinating concept called Faraday quarters. So in classical physics, Michael Faraday figured out that electromagnetic fields can rotate in quarter turns, basically 90-degree shifts. But Dr. Rihan takes this classical idea and totally elevates it. In his model, a Faraday quarter isn't just some mathematical quirk. It's a fundamental quantum operator. It's literally the physical, mechanical engine driving reality. It's like an instruction from the universe saying, hey, take this physical layer of an atom and turn it exactly 90 degrees.
And this is where Dr. Rihan makes such a brilliant leap. See, in classical electromagnetism, these quarter turns just dictate things like the polarization of light or phase shifts in a wave. But when we look at quantum wave mechanics, he merges these two worlds. In his framework, these Faraday quarters dictate the actual physical 90-degree orientation of particle layers as an atom is forming. So the wave function isn't just some abstract graph of probabilities anymore. It actually carries dynamic physical orientational instructions inherited all the way from the Big Bang. So how does the math actually execute this 90-degree turn? Well, the answer lies in Euler's formula, combined with the imaginary unit, which we call I. Now, in standard math, I is the square root of -1, and when you multiply by I on a complex plane, it visually represents a 90-degree rotation. But Dr. Rihan proposes something revolutionary here. He says I isn't just an abstract or imaginary concept at all. It's an active reality operator. It physically forces 90-degree rotations in the construction of an atom. It's a very real instruction set telling the building blocks of the universe exactly how to align. So we have our rotation engine. Moving into section 2, building the atomic core, let's take a little construction tour and see exactly how this engine builds an atom layer by layer, right from the center. Imagine you're watching a microscopic 3D printer building the core of an atom around its central triple quark initiation point. There is this rhythmic step-by-step sequence to it. Step 1, the very first attracted layer, the neutron layer, aligns to a primary direction and revolves around the core. Now, that moving neutron layer generates an electromagnetic field, which induces the next layer, the proton layer. But it applies our active reality operator, the imaginary unit I. So, step 2, boom, the proton layer is rotated exactly 90 degrees. Its orbital plane is completely perpendicular to the neutron layer. Then this proton layer's wave function affects the next layer. Step 3, the antineutron layer is pulled in, but it aligns in direct opposition to that very first neutron layer. Okay, so what happens when you build a core like this? You get what's called the 90-degree sandwich effect. Because of those successive 90-degree rotations, the perpendicular proton layer gets tightly enclosed, literally sandwiched, between the opposing neutron and antineutron shells. And this specific geometric arrangement is absolutely crucial. It ensures electromagnetic opposition, it creates perfect torque balance, and it achieves what Dr. Rihan calls local MEE, magnetic electromagnetic equilibrium. The core becomes incredibly compact, dense, and perfectly stable. And it's all because of these alternating 90-degree right angles. All right, we've built the incredibly dense, tightly sandwiched nuclear core. Now, in section 3, the vast electron envelope, we arrive at the climax of our atomic construction project, the outermost layer. To really understand the whole atom, we have to compare those compact inner nuclear layers we just built with the outermost electron shell. And the key difference here? It's all about external forces. The inner layers, the neutrons and protons, are incredibly compact because they are constantly being pushed inward and balanced by the subsequent layers building on top of them. But take a look at the electron shell. The electron layer is the end of the line. It follows the cumulative chain of rotations, sure, but there is no outer next layer to exert an inward push or force another rotation. It self-attracts to the nucleus and it self-repulses against the inner layers, but it completely lacks that final inward squeeze.
And that brings us to a really crucial point, the culminating gap. This perfectly answers that huge question we asked at the very beginning of this explainer. Why is the atom mostly empty space? Well, it's not random. The characteristically large free distance between the tightly packed nucleus and that diffuse electron shell exists precisely because of this mathematical chain of events. The cumulative phase rotations stabilize the electron cloud as the final envelope, but the absolute lack of an outer inward push allows it to sit far, far away from the core. The emptiness is literally a direct physical manifestation of the math just running out of layers to rotate.
So we've solved the mystery of the atom's empty space. But Dr. Rihan's framework doesn't stop there. In Section 4, Unifying the Cosmos, let's zoom out and look at the grand implications. This timeline is just breathtaking because it unifies the entire cosmos under a single mechanism. According to this model, it all starts at Phase 1, with the primordial four-cloud pendulum collision of the Big Bang. That collision sets up Phase 2, which is a fundamental, perpendicular 3D scaffolding made of quarks. And that primordial perpendicular geometry is exactly what we just watched play out in Phase 3, the precise nuclear layering driven by those 90-degree Faraday quarters and Euler rotations, which finally leads to Phase 4, the equilibrated electron shells with their vast empty space. You have macroscopic cosmological origins and microscopic quantum physics completely unified through rotational wave dynamics.
And it honestly all comes down to a single number, 90, a 90-degree shift. A quarter turn. It is just so profound in its elegance. In Dr. Rihan's framework, quantum rules apply uniformly from the subatomic scale all the way up to cosmic scales simply because this 90-degree rotation is the universal law of construction. It is the synchronizing heartbeat that dictates stability, balance, and the very geometry of space itself.
Now, I know what you might be thinking. Okay, this is beautiful math, but is it real science? Yes, absolutely. A strong theoretical model has to make testable predictions, and Dr. Rihan definitely provides them. Because this model dictates very specific phase relationships and rotational dynamics, researchers can actually go look for multi-Gaussian fine structures in spectroscopy. They can look for anomalous magnetic moments that would naturally arise from the cumulative torques of these spinning layers. They can even look for layer-specific selection rules when atoms transition states. This isn't just philosophy, you know. It provides a concrete roadmap for future empirical observation in the lab. I want to leave you with this incredible quote directly from the source material. The universe builds itself through successive 90-degree reality rotations, echoing how complex structures emerge from simple orthogonal principles established at the Big Bang. It forces us to ask a really beautiful, provocative question. Is the immense complexity of our entire universe, including the vast, mysterious empty spaces inside our own bodies, ultimately nothing more than the stunning result of simple right angles, echoing outwards since the dawn of time? It completely changes how you view the world around you, doesn't it? Thank you so much for joining me for this explainer, and keep exploring.